Welcome to qnawire.
Hello student, the given information is that n1 equals to 30 and the sample mean related with the first sample is 135.63 and the sample variance equals to 4.04. Next sample size equals to 30 and the sample mean corresponding to the second sample is 131.37 and the sample standard deviation equals to the 5.13. Here to test is there evidence that the mean skull width change over the two time periods. So to test, the null hypothesis is that mu1 is equals to mu2 versus alternative hypothesis is that mu1 is not equals to mu2. This is the null hypothesis, this is the alternative hypothesis. Now in a B part we have to find the sample statistics, and the sample statistics is given by x1 bar minus x2 bar, and we know the both values. The value of x1 bar is 135.63 and the value of x2 bar is 131.37. Simply put here and simplify it, we get the value is 4.26. Now in the next part, compute the value of the test statistics. So the value of formula for the test statistics is given as, here we are going to use the t-test. So t is equal to x1 bar minus x2 bar divided by standard error. The value of the standard error is also given. Right down here, standard error is equals to 1.1922. So we know the all values here, just put, and after simplification we get this value of the test statistics as 3.5732. Now in the next part we have to find the p-value, and the p-value corresponding to this test statistics by using the stat key, we get this value as 0.000718, and the value of alpha, which is 0.05 in general, which is not given, and we take it always 0.05. So if the p-value is smaller as compared to alpha, so we reject the null hypothesis. So the conclusion is that there is significant difference between the two skull width, and to find the p-value we require the degrees of freedom, and the degrees of freedom which is equals to n1 plus n2 minus 2. n1 equals to 30, n2 equals to 30 minus 2, we get this value as 58. So by using the t-statistics and the degrees of freedom we get this p-value. Now in a next part they are asking that if we find the significant difference between the two skull width, then the researcher is interested in the 95% confidence interval. Then 100 into 1 minus alpha percent confidence interval for the difference of the mean mu1 minus mu2 is given by x1 bar minus x2 bar plus minus t alpha by 2 with n1 plus n2 minus 2 degrees of freedom into standard error. We know the value of the standard error. First calculate this critical value. The value of C, that is given as 95%, that is 0.95, then alpha is equals to 0.05. By using a formula, alpha equals to 1 minus C. Now calculate the critical value T alpha by 2 with n1 plus n2 minus 2, which is equals to T alpha equals to 0.05 divided by 2 with n1 plus n2 minus 2, that is the 58 degrees of freedom. And by using a table we get this value as 2.0017. So put the value here, and this whole term is known as the margin of error, which is equals to 2.0017 into standard error. The value is already given, 1.1922, and after simplification we get this value as 2.3834. This is the margin of error. So to calculate the lower confidence interval, we require the formula x1 bar minus x2 bar minus margin of error, and the upper confidence interval is equals to x1 bar minus x2 bar plus margin of error. We know the all values, just put here, and after putting the values we get the lower confidence interval equals to 1.8736 and upper confidence interval equals to 6.6464. Now we have to interpret the result. Therefore we can say that we are 95% confident that the difference of two skull width is lies between 1.8736 to 6.6464 in this confidence interval. I hope this video is helpful for you. Thank you.